in terms of how they are even approached. There is an aspect of it which is curated to this patient based on different clinical facts. We typically talk about it from terms of this, again, the healthcare space is called UMLS, Unified Medical Language Standard, basically. So basically you have these, again, I might be missing up the abbreviation of UMLS, but again, it's basically the standards based on which you characterize different things like medical conditions, medications, and so on. So we do that. So that's the first agent that we leverage, which, as I talked about, leverages semantic routing, intent identification, and creates a summary. So the second piece that we do,
should I interrupt you for?
Yeah, you can go ahead. Yeah.
Okay. So yeah, one question I have is, do you do some sort of prompt structuring engineering?
Yeah.
Yeah, for that agent specifically.
Yeah. Has to be.
You have to have like I'm guessing you have like a lot of test cases in production that prompt should go through before it goes through the model, or how does it work?
So like when you go ahead and deploy these things in production, you also have this long-winded QA and UAT period where you are verifying it against business users as well as your QA team. That's the place where you iterate and make sure that it reaches a certain threshold. And I mean, we don't necessarily do it for every single run, and it happens during production, if that's what you're talking about. Yeah. But so it's done before we actually go into production. But in post-production, what we do is we have a fallout report where we take like 5% of the cases and we ensure that they're all sticking to standard. And then users can also provide feedback. Again, what you're seeing here is not the actual user interface that they have. It's more of our interpretation of the UI, because as I said, most of our work is backend, so we just plug into like the backend. So that's the first. Yeah.
May I ask a little clarification?
Oh, yeah.
Kind of that same question. What foundation vision language model did you use? And then which of the techniques prompting, everybody has to prompt.
Yeah.
But then there's RAG, and then there's fine tuning.
Yeah.
To get that level of performance, what did you do?
Yeah. So I can't give you the specifics of the language, the vision model that we use, but then it is in the layer detection space. So there are multitudes of like models which are in the VLM space, particularly the ones which are like layout detection based. And in fact, I don't even know the exact name of the model that we use as a.
It's open source.
It's open source, and then you go ahead and build your own proprietary model.
And what did you find was, it's a cost ladder, right? Prompting is cheap, RAG is in the middle, and then fine tuning is quite expensive, relatively speaking. How do you navigate that, and what did you do to get that?
Yeah, that's a great question again. So when we look at this fine tuning, I think it's a tall order. Like not a lot of people, in fact, I think on the application layer level do a lot of fine tuning, because it's easier for you to, especially when it comes to open source, even though it's cheaper than building your own model, foundation model, it is far more expensive to fine tune as well, because you need, not just in terms of expense, but also from cost perspective, you need to, use it. It takes a lot from inference perspective when you're having these GPUs. To host these and run those, so to tune these models. So, okay, all right. Yeah. The way we landed on this the summary that you saw earlier, in fact, is leveraging RAG, and that's where I said we do there's some aspects of semantic routing and intent identification, is because once you identify what exactly the user wants, in this case, to create a summary based on certain artifacts which are there in the clinical document, like your diagnosis and procedure. We ensure that we create a summary, and we ensure, essentially we leverage RAG. So identify semantically similar chunks, and there's this whole aspect. I can go specifically about the summary itself, where we ensure that we have the right embedding and chunking models, ensuring that they are all indexed properly in the metadatabase and so on. So we did land up on RAG essentially to answer your question.
Yeah.
And go ahead.
Emphasis on RAG. Okay.
Yeah. So that's the first. Go ahead.
Quick question. So this is all healthcare data, right? So EHR data and patient records and all. So are you hosting your own models? Because again, if you provide it as a service to a provider, they would either want to host it themselves or not want the data to leak, right? So how do you usually tackle that?
So again, this one, just to be clear, it's all
this is just an example, but
example. the way we operate in our, like, again, it depends on the client, but most often than not, as you said, they would like to host in their infrastructure. So especially they wouldn't want data going out, and we, like, abide by that. We are all, but I mean, we are also HIPAA compliant and we have all the right certifications, but it is the case that, in our clients would like to host, especially because these are like huge Fortune 100 and Fortune 500 players. So we do it, like, deployed in their environments.
So it's the HIPAA regulation that's going to be the biggest problem, right? Do they take ownership of that, or do you do it? And are they in a major cloud service, virtual private cloud kind of thing, or what?
No, I mean, I don't think anybody is on-prem these days, but they do have like some cloud provider. But it's their environment.
Sure, yeah, okay, all right, that sounds, yeah, that could be a virtual private cloud in AWS, for example. Okay.
Yeah, and even though, I mean, we don't see that necessarily as a problem, because we don't want to take anything out. Essentially, when we do these custom fine tuning and we have or any of model development that does happen, especially on the language model side, sorry, vision model side, we give it to them, and it's their own property. We don't necessarily take it out or leverage it for our other use cases. That's something that we assure to all our clients.
But you're going to need to, you have a RAG database that's interpreting, that teaches all the medical terms or whatever you're doing, right? And it's going to keep getting updated, right? So it's like a subscription. Do you keep updating? Is that the plan? I mean, they got to copy it into their environment, but medical technology is moving, right?
Yeah, I agree. But I mean, I'd like to, like, if it's okay, like, what do you mean when you say, like, updating terms? When it comes to RAG, it's pretty much, you have an infrastructure in place, and that's about it. Like, you might possibly fine tune the prompts. When I say fine tune,
they're searching over all the data. So for individual, like, I think when you're talking about RAG, you're not necessarily searching, like, to answer or to generate a patient summary or to generate an answer for a particular patient. They don't need to search over all the documents, right? They need to only search over a specific document, like 17 pages in this particular context. So
no, I mean, well, I'm sorry, we probably ought to let you finish your whole framework. It's a good discussion. Yeah, I'm sorry.
So the second piece that we do is guideline compliance. So again, from a value perspective, what we also do is this is more, I would say, related to you might resonate with what you just said. So what we also do is, for this document, in the healthcare space, you look for medical necessity. What you essentially mean by that is, for each of these documents, are these is this patient qualified for receiving the appropriate treatment? They call that medical necessity. And what we do is we verify it against the guidelines. So again, for the purpose of this example, we have taken some publicly available guidelines, but we also provide compliance and make sure that the patient is compliant with the guidelines that are being referred to. So what we also provide on top of that is provenance. So again, very similar to when we establish that these are the guidelines that we're verifying, it's always good to show where exactly did we take these guidelines from. In this case, we've ingested like thousands of documents, and in this specific case, as you can see, page number 26 of this particular document, we've highlighted the specific portion that we're taking from as well. So always tying it back to the source is useful in two ways. One, from an auditability perspective, because you always can go back to say that this is where we put the data from. And secondly, it also helps in ensuring that there is trust in the system, especially as we are in this age of folks starting to use AI. It becomes imperative that you establish trust, and that's what we try to do with this product. And then there are other use cases as well. This is a product that's it's growing. It's taken its course in terms of all the different use cases that we support. One of the use cases that we support is we also tap into multitude of databases and try to provide other contextual information about this patient, so that it's not just this single 17-page fax that you see that's providing them insights about the patient. But what if they had like a surgery the previous week, or something that's happened to them the previous month? Will that influence decision making? How do we gather that information? It could be through previous authorizations, previous claims, and so on.
Yeah. So how good is this guidance compliance agent? Like, does it make mistakes in production? Like, if so, how many mistakes did you see?
Right. And I think that's probably the biggest question that people would like to know in terms of how do we move something like this to production, right? So so the way we did this is we have, okay, just a a second, I'm just trying to see. Okay, it's not. No, it's fine. I think I can come back to this later. But yeah, yeah, I think it's fine. Yeah. So, okay, looks different. Yeah. So the way we do it is we have like our own I would say a team of nurses who help in validating the work that we've done before we go to production and ensure that we reach a certain threshold. And we establish this threshold in different ways. Like basically we have a scorecard that we give to our clients, which tells them that, hey, this is our performance. And I don't have that handy, but essentially that's the way we establish trust in terms of the system and the process. So once we have that, where we've been able to say that, okay, of the hundreds of cases that have been evaluated in these different diagnoses and procedures, and different, I would say, lines of business, basically, inpatient, outpatient, and all that stuff. We essentially ensure that we prepare these multitudes of scorecards and provide them to our clients.
How much of it is related to the LLM hallucination, or how much of it is related to the OCR?
OCR, I mean, OCR isn't, I would say, we do evaluate obviously our performance, but then as I said, our vision model essentially takes care of, is our primary use when it comes to the data extraction piece. So we don't necessarily rely on OCR, but we leverage these different models, and I would say all our metrics that we characterize and we capture are predominantly related to not just the LLM, because I think that's a simplification of the entire thing that we do. Because because it's not just the end piece where you push it off to a large language model, and
But it's just my personal experience that OCR, especially in these situations, is incredibly hard.
Yeah, it is I would definitely say that's one of the biggest bottlenecks that are there, and that's why we came up with our own vision model, which seems to be performing well, especially when it comes to these kind of access that we see.
How do you guys tell whether it's getting better or worse? So like you run a certain application and it's for a particular form, and you have the nurses checking it and they give you a score. Now, how does your performance regression work? In other words, they're going to fix something, they're going to change something, maybe they prompt differently, they're going to change the RAG database. How do they tell whether they made it better without screwing up something else?
Yeah, it's a fair question as well. So while we do go and deploy these solutions, obviously there's an initial testing phase, but we also have continuous evaluation. So especially if you want to go deeply on the more technical on the engineering side, we route like a 5% or a certain volume percent of all the faxes that we process, and we do it basically you get both the the validations that were done by the nurses or the technical folks who are there in the medical side, and then what we have produced, and we do a like-to-like comparison. So every time we do go through a deployment, we see how the performance is of ours compared to that what a nurse would do. So we don't necessarily say the technical staff out of the picture. They still evaluate certain number of these faxes, and while they evaluate the faxes, we also ensure that we evaluate them through our model and we do a comparison that goes through our data science team.
So you take their edited fixes, right? And you see if you get closer to them in some semantic space.
Yeah, exactly. And also not just that, but also if say in terms of the final results and the adjudication as well, which is what we're doing here, were we able to adjudicate it at the same level? Because when we talk about say semantic similarity, it more relies on say things like the summary that we create or the certain aspects of the Copilot that we're seeing or the product that we have. But then certain aspects which are not related to the summary and which is related to performance or end results are not necessarily looked at from that lens. We're taking a more fine-grained case-by-case approach.
Okay.
So 2 questions. I was a little late in the beginning. So essentially, are you taking this form, scanning it, and then taking that information, or is it like an ETL job that's running between to extract different parts of the data and then put into the LLM and then it's transformed?
The way you put it is giving LLM a lot of credit, because that's just the last piece of the puzzle, especially for certain pieces of what we're trying to do. the ETL piece, again, it's not directly ETL, there's an aspect of converting the data, obviously structuring the data, which is what our first use case does, essentially the extraction piece as well as the summarization. And then another aspect of it is creating the compliance. So yes, there is like there are these LLMs that are involved, but the more important aspect is making sure that you have the right guidelines in place, the right guidelines that are retrieved. So the RAG infrastructure, I would say, plays a larger part here. And yes, finally there is an aspect of an LLM that's being used. So yeah.
Okay, second question. So the whole idea of LLMs is just predicting what might be said next, or
Next token prediction.
Right.
Yeah.
So how do you get more control over like the predictive capability of it? Because it can go all around the place sometimes, and sometimes mixing things up. How do you get more control over that? I know you can fine tune, but like, is there something else you do? Especially working in a space like this where you have health compliance and all this stuff.
Yeah, that's a question that we're still actively trying to solve. So it's not, I would say, easy easy problem to solve.
Yeah.
But there are multitudes of aspects to it. So I think the most, the common, well-known aspect is something called temperature, if you're aware of these LLMs. So that's an easy way to say that we set temperatures to 0 because we want consistency in results. But I think everybody does that. I think another aspect that we try to do is there are different levels of grounding that we do. So anytime we get these results at any juncture that you see, especially when it comes to these agents, we ensure that they're grounded against another small LLM, basically, which evaluates the output of this LLM. And when I say on this step, not LLM, I would say, yeah, to ensure that are we on the right track. So that level gives you course correction to ensure that grounding is in place. So that's point number 2. And then there are also aspects of ensuring that you choose the right model as well. So we've used open source, we've used closed source, and we've seen to have gotten I would say a good level of performance when it comes to certain open source models. So and also one thing which we realized, which is very funny, is although all of these models are trained using, they say, everything under the web, there is definitely, you see differences when it comes to certain industries. And I would definitely encourage you all also to make sure that because for example, again, I'm not saying that's the case here, but Claude may be a much better option when it comes to the industry that you're working in compared to Gemini, even though they basically say they are trained under the same level of data sets and they have the same number of parameters and so on. So it depends, I would say.
Have you tried to that question, have you tried the RAG assessment toolkit, RAGAS?
Yeah, RAGAS, yeah. We do that at our end, yeah. We don't use a third party, we do it at our end, yeah.
You do it?
As in, we developed our own RAGAS based evaluation. It's just an evaluation framework. So
yeah, it's a framework, yeah. And there's, I don't know.
No, it's
open source, there's hundreds of guys trying to solve this problem, right?
Right.
And have you tried it, and did you find it effective, or did you have to build something from scratch, or it's for measuring.
Yeah, I think there are 3
quantitative, non-human measurement of whether you're getting better or worse.
Yeah, maybe this is where I pull up I'm the product manager guy. I'm not the technical guy.
Okay,
but
all right.
But I can.
Sorry about that.
No, I can definitely give you an aspect. I can talk about say we do when it comes to RAGAS, I think one thing that we look for is faithfulness. I was a part of the discussions. There, I think somebody who's more technical can talk about the other aspects, but there's faithfulness. I think there were a few more different metrics that comes out of it, which is basically like a metric rather than a subjective take. So yes, we did do it. I might not know the exact specifics of it. So
okay.
yeah, but it is more I would say present in our other products, which are more RAG based compared to this. But yeah, it was done for any RAG infra that we build. And then finally, we also generate a recommendation and a compliance report. So, the screen is glitching a bit, but essentially what we also do here is we create a recommendation that that the nurses can use for the downstream processing. Essentially, this is our take on what exactly has happened during this process of evaluating this patient's condition, and we believe that this is the specific guideline, this was the observation, and so on. So this gets a bit intricate in terms of how we evaluate this, how we do this. Again, it's an aspect of RAG plus good level of prompt engineering. But yeah, you essentially create the format that we need, and then this can be used, especially in this specific use case, to create certain letters as well. Because in the end, what you want to do is ensure that you communicate to the client. So yeah, so this is the overall process, and yeah.
Good question. So does maybe about the use case itself, not
Yeah.
the use case or maybe the input reports. Do these reports also contain things like all, like let's say a patient had a comprehensive blood panel done, so the output report, output answers of like what the different values are for different blood groups or all those different tests. So the results of the tests basically. And does that also cover over time, right? Like, so you might have, let's say, 10 particular follow-ups of a particular patient with all these different reports, all these different hundreds of numbers spread around somewhere in the report. Do these actually cover these things? And if so, like, do you have a special way of handling such tabular data sets? Because
so
typical RAG-based frameworks will not work really well on these.
Yeah. So let me put it this way, especially when it comes to these use cases, you don't want to know, I mean, obviously you want to know what the patient has gone through their entire life history, but what you're trying to judge or what you're trying to adjudicate, which is what the nurses do, and what we help them with, is the latest case or the most specific case. So your, like, the set of consideration is not the entire thing.
So basically you mostly focus on the current report or current
because
assessment.
I mean, yeah, somebody had a fracture 10 years ago, but doesn't mean that you need to.
No, but like there
update the
can be
fracture, right?
diseases in which like a patient has to be followed up over time, right?
So
So like
yeah.
like I primarily work in so I'm a pharma company, I primarily work in cancer, so you do have to like
Yeah.
follow up a patient every month to see, let's say, whether tumor size is increasing or decreasing, or whether this particular
Right.
marker in the in the blood is increasing in count or decreasing in count.
Right.
And there can be 10 other things which you have to
And so we have another product in our, like, we call it the Copilot called Clinical 360, Patient 360 Copilot, which does essentially this. We map the patient's history across a timeline, and we basically can say that, okay, they've gone through so and so procedures, and then it's just a matter of then, like, predicting when the next test should be. I would say we do that to an extent, but not the use case that you are specifically talking about, because we don't deal with cancer. But yes, I think it's doable, but it's not this use case though. So yeah, so this is the recommendation piece. Again, I would say this one is very similar to what I just talked about earlier, and the users can at any point in time give us feedback about how we're performing and so on. Yeah.
Along the same lines of this recommendation piece.
Right.
So right now, this is, like you said, is a letter that can be sent back to the patient's doctor or whatever,
Yes.
whoever is the person who will tackle this.
Yeah.
Did you like try integrating with APIs?
Yeah.
After this point downstream for downstream process.
I mean,
Yeah.
also we are, like, our company is AI focused, so we don't necessarily get into the ops piece of it.
Okay.
But I would say, is it a problem that can be solved? Yes, through APIs easily. And one thing to also note here, I think, which is very important in our thesis when it comes to building products, is we always rely on something called human in the loop. So although we've taken all these different things, essentially what we're trying to do is make your work faster. We don't say we take the choice, you just we do everything, and there's nobody to evaluate what we're doing. So that in essence helps in two ways. One, it makes sure that somebody who's actually clinically trained can see what we're doing, and we're just making it faster for them. And then the second is also making sure that the burden of responsibility is something that's being considered seriously, and it's being, because all our healthcare clients, in this case the insurance payers, so on, they want to make sure that they are in the process, and they don't want to make sure that it's completely automated. So it's being taken very seriously.
So this question, what are the different data sources that this pulls from?
In this case, it's pretty simple. It's just two data sources. One is actually, it depends on, I would not say simple, let me take that back. But there are, in this specific use case that you're seeing on screen, it's the patient facts, which is one critical data set that you see here. And then the second is all the policy guidelines that's being used to adjudicate. So you have these two data sources.
So it's stored in like EMR or something connected?
Yeah, we do have EMR connectivity. So we work with all these different EMR players. If you're aware, Cerner, effect and so on. So yeah, we can tap into their databases and basically collect them. But specifically, like in the use case that I'm showing here, it can be these documents can be stored in any blob store, and again depends on the cloud provider. This one I think is set up in Azure, I guess, so that you have your Azure blob storage. Yeah, but so that if there are no more questions, this brings me to the end of what I wanted to present. But yeah, so go ahead. Yeah.
Are you ingesting any data that's kind of closer to real time, like drug delivery or heart rate monitors or anything like that as part of this?
In this use case, no. Let me see. I mean, I don't know if I can. Yeah, I mean, yeah. Well, the long story short, yes, we do ingest real-time data, but then I would say a good portion of our use cases are asynchronous, so they don't happen in real time as well. So we basically send them in batch. We make it available so that it's just a matter of calling whatever we've stored as an output into the response. So that's I think most of the use cases, but yes, we do deal with real-time data.
What's like the typical time to regenerate a summary for a given patient?
Yeah, exactly. I think that's the point that I was trying to interact is we make sure that everything is ready before they start their process. So like the latency is almost instantaneous when the user is actually using it, because the triggering process for this is when the user opens the trace, but then we pre-processed it the previous night because we've received all the faxes and we've had it ready.
Okay, I guess it's like every day, basically.
Yeah, it's every day. Yeah, we like the volumes that we tackle are in the orders of millions in a year, every year. So yeah.
Cool.
Yeah. Thanks. Yeah.
Can you talk a little bit about your business model, revenue, profit? Are you guys profitable?
Yeah, I mean, yeah, it's public information, I guess. Or when I say public, it's on LinkedIn
Okay,
and all that stuff. Yeah, I don't think I should.
Are you publicly listed?
No, we're not publicly listed. No. I said when I say public, it's like on LinkedIn. I think we talk about like say our growth and all that. So just to give an overview, we were like a finalist last year in South by Southwest in the AI category. So, but then we don't like.
Or how many customers do you have?
Yeah, those figures. I mean,
What's the name of the company?
Autonomized AI. Yeah. I mean, I don't think I should be the one saying that, but we can have an offline conversation.
Okay. Or like, can you talk about, are you Series C, Series B?
Yeah, we're seed funded. We're like, we raised our funding last year around June. June 1st, I think. Or actually slightly earlier than that, yeah.
And what is your employee count?
Yeah, we're in the orders of 10 to 100, like probably around 50.
Okay.
Again, it's fluctuating because you also have I mean, as you
That's
grow.
some other people.
Yeah.
Awesome.
So I'm curious on what are you claiming for the effectiveness? Like, is this problem solved, and very rarely you need human intervention, or is this still kind of coming out of research, or what's your thought on maturity of this type of technology?
So we have like clients who are paying for this at the moment. So yeah, it's like out of the research labs and into the market or into the wild, as we say. However, I would say like in terms of intervention, the way we think about, as I said, is human in the loop.
Yep.
So it's not the case that you just let this machine run wild and you don't look at it and then you look at 5 days later. So most of the cases, again, we provide as part of our output also certain confidence scores to ensure that folks have the comfort. So when we have like, again, it depends on the clients as well because we closely work with them. They have different queues as well. So there is always an exception queue where we've never processed any single data. Could be because the facts basically bad. And then there's also certain queues where it's low confidence and high confidence. And that depends on the level of effort and all that kind of stuff. In essence, yes, you always have folks taking a look at it. And what we are providing as a value prop here is the time that's saved during the process. Yeah.
Do you have any way of, this is right on the edge of research now, but do you have any way of flagging the parts of the answer or the output which the system knows have less matching to, say, stuff in the RAG database or stuff in the form? And in other words, drawing the attention of the human in the loop.
Yes,
to
I think
particularly look at certain portions that the system's not confident in.
Yeah, I guess so that's where our confidence score comes in, where we don't give like a single one single conference call that's there, but it's an aspect of highlighting through the different processes. Because as I said, we have like multiple agents in the workflows.
But
Every single agent.
in the guidance compliance, they talk about where the guidance mismatch, the compliance mismatch happened, and they draw the attention to the exact source.
Yeah, that's right. And
Yeah.
that's the kind of thing that helps, right?
Yeah.
And some of the tools for measuring performance, and I think some of it's in the RAG-S suite, for example. They match sentences in the output with sentences in the sources, right? And it can start to tell you where the language model was filling in stuff that it didn't pull directly out of the sources. I think you know what I'm talking about.
Yeah. I mean, again, this is more talking outside of the scope of this Copilot.
Okay.
But at least where I've seen all of our products and even sources out there, if you have like very good guardrails in place and you have typically if you constrain the RAG to a certain set of documents, hallucination isn't as bad as how it comes when it comes to say just having a large language model doing it on its own. So yeah, I would say yes, it's a problem, but the percentage of incidents I would say is much lesser than just having an LLM.
Sure, that's the main point of RAG. I get it.
Yeah,
sure, of course.
So what does success look like? What are the KPIs you all measure to?
So that's so it depends on again so because we provide all these different, so this is like the combined experience of Copilot, and what we do is we also have these fundamental building blocks called agents, and in this case you have data extraction agent and the summarization agent. Again, all of them work independently, and then you have an adjudication agent, and then you have a recommendation agent. So all of these different agents have their own KPIs. Again, it depends on what the agent fundamentally does. Because in data extraction agents, the KPIs are more along how accurate the extraction was, how many, again, depends on how many fields. So in this case, there are 20 fields that you need to extract in this case. So how many fields were you able to extract and so on. So I would say it's not easy for me to just say, okay, these are the KPIs because fundamentally it differs based on the use case.
So is it different experiences per agent, like end user experiences per agent, or is it all of these agents are combined to have one general experience?
It's again because we're deeply integrated with our client's ecosystem. They don't necessarily see these agents. They don't know what's happening in the backend. The reason why we've called them as agents and they're also separated out is because some of our clients have their own systems which are vastly different than other clients.
Right.
So we want to make sure that we give them the flexibility that hey, if this is the focus that you want to have right now, then you can just integrate that agent and go and have that. So they don't necessarily so the question or the response is that they don't see anything. Their user interaction with the agent is basically non-existent. They only see the outputs, and that's tightly interconnected with the agents and the customer's workflow.
There is no way in which like the end user is triggering an action on your end. Right? Like everything is curated beforehand. So the agent and the curation and processing is happening, and the users are just interacting with the processed information. They're not like active in the sense that the user says, this information is missing, go for search for it in the data.
That was mostly a design choice, but it doesn't have to be. I can easily tell in this case as well where we might have to, like for example, when it comes to say generating a letter. I think what we focused on is making sure that it's time, it saves time. So when we think about things like say generation, and there is an aspect of an open source model or an LLM involved, it does take time. So so we want to make sure that we it's all done beforehand. But again, I do not think that's the only way to do it. And in fact, there are other use cases of ours which generates data dynamically because you need user input as well. So when there is a user input involved, for example, when let's say even in this case when you're generating a letter and there are certain aspects of it which are wrong, or in the previous step it was incorrect, and the user can't change the response. So then you're triggering an action which can create the letter dynamically.
So
but
you
again,
can intervene and then change things, and that will trigger the rest.
Yeah, that will trigger the rest of the pipeline. Yes. But yeah, it's I would say I think the most imperative or the most important thing is customer satisfaction. So we believe that this one does not necessarily, I would say, hamper the customer experience what we're doing. However, if it does, then real time generation would be required or performance is required.
Okay, give a round of applause for presentation.
And happy to chat more. I mean, especially since so many folks here later as well. So
Yeah, definitely. So we'll have a cool round of facilitated networking after the talks. But before that, let's welcome Betty, our second speaker.
Sorry, just trying to beat the traffic. Have to travel over to San Antonio today to meet with a customer, and then the traffic back is really crazy. So sorry about that. So well, this is actually my personal the second event that I've attended was at AI Jupiter, which is such a order. What basically I want to showcase today is actually now if you look at AI development, LLMs, Gen AI, majority of them are related to softwares. Most of them, the applications we're doing is mostly digital, which totally makes sense because that's where you need the LLM to play in. But our company, I'm from a company called Seek Studio. We focus on building open source hardware. That's what we do. And then for the past almost 10 years, we're primarily focusing on building IoT devices, which basically are mainly sensor devices that you collect the data from the actual physical world. And then what it used to be is that you connect that with a control system, or you have your dashboard. And then you look at all this data. If you click on it, you'll be like, okay, my room now is 30 degrees. But that's pretty much all it does. So in a world of IoT applications, what people it was really fast moving and then developing for a period of time, and then it kind of stopped. And then the problem is that you get all of this data, but then they're just data. Nobody's doing anything with it. You have a bunch of data sitting right there, and then you don't know how to utilize it. And then when the company is starting to adopt and understanding the concept of using sensors to get all this data, the problem is that they all just have a dashboard. That's all it is. We build IoT stuff. This is a dashboard. But then what do you do with the dashboard? They don't know. At the end of the day, even though right now the most advanced ones, what they do is that they have this expert group of people who can all this data. When it's something triggered, they're like, okay, I'm clicking on this so that I can automatically, or not automatically, manually control on and offs, or something smarter right now that people are more familiar with is, for example, smart home applications. So now that you can see okay, so if the temperature goes over that, kind of control my air conditioner to drop, turn on and off, heaters on and off. But that's very basic process. It's sort of analog, right? It says you meet this criteria and you do this function. But what we're thinking now, we're looking in the age of AI, and then AI is more of a tool that can kind of help understand more in depth on what's going on, not just one number, but it's so much more. So we're actually building this little gadget devices. I'm going to show you guys how it works. It actually works. So what it does actually is what we call a physical AI agent that combines and bring the power of LLM to the physical world. So if you look at this devices right here, right now I'm running a little power. So it has a AI embedded camera, on-device camera. So that's fully running on device. So what it's able to do is that it has AI capabilities of doing object detections. It could be a person, it could be a chair, it could be anything. So a small model that's being able to detect what you're looking for is at the current day fully capable of running on MCUs like the small devices here. You don't need to connect with any large models, internet or anything. It's running right here, and it's ultra low power, which means that it can be powered by batteries. And then once it's here, what do we do that with LLMs? So one of the things we mentioned like LLMs can do is that it can understand more in depth of what it's seeing. So what it used to be is that you give them an idea of like, okay, now I'm programming, I'm writing like a algorithm of like detecting a person. That's, you spend 2 days maybe for the good one, good people, building this AI model, but that's all it does. All it does, this one model is to detect person. And then for the next time, if you want to build like something that's, okay, detect a chair, I need to write another model. And then what about more complex ones? What if I, instead of telling me there is a person right there, tell me if the person is, I don't know, wearing a hat. Tell me the person is sleeping. Tell me the person is, in a way, like, if I fall asleep, like snoring. These are all like what we need more is like the more in-depth analyzations of not only one sensor, but like the overall environment, and feed that data, that information over to LLMs. And then LLM will use its own intelligence to kind of comprehend what is actually happening in this scenario. So basically, the reference design we were really doing here is that we basically build an infrastructure or like architecture to run like LLM. Of course, right now it will be like, right now we're using like the popular ones, like you can use OpenAI like for all, you can use like Llama. If you have like a Llama or a desktop, you can use that as well, so that we like fully deployed on Edge. So on the LLM side, what it does is that you can give it like a natural language command. So as I mentioned, you can just sort of text, oh, like I'm looking for a person wearing glasses, or I'm looking for a person wearing, I don't know, like a blouser. So you can just text this simple command with natural languages, send it over to LLMs. And what LLMs is going to do is, one, understand what you're looking for. Two, is to make it more efficient, is sort of like breaking down. Like, that is what all agents do, right? Understanding the task, breaking down to smaller tasks. So what it's able to do is that with the on-device model that we're able to run like object detection, it's going to understand, okay, I'm looking for these like what we call like a model zoo. We have like 300 object detection models already, like small models already there. So what I'm going to do is that I'm trying to like, if I'm wearing like, for example, like if I'm looking for a person who's wearing a hat. So there's two things I'm looking for, a person and a hat. So LLM will go through all the model zoos to look for if I have a person detection model, or if I have a hat detection model, and select the ones that is fit in this scenario. And then what it's able to do is that it kind of break down that to, okay, I'm looking for a person first, and then I'll see if that person is wearing a hat. And if you confirm that breakdown, the small model will be OTA, like which is like flushed on the air, which is they're like Bluetooth directly on these devices. And then the other tags, it will be landed on LLM. And the reason we do that is that in actual use cases, you don't really need to run every single image on LLM. Like, that's very expensive if you're using cloud, or that would be a latency. If I'm looking for a person wearing a hat, there's no person in the room at all, why would I send those photos or pictures to LLM to analyze them, right? So what we're doing is that we're using like a fast way in regards of kind of enhance the efficiency of it. For this smaller devices that is able to run on batteries, we put it on the far edge to do a triggering event. And then only the first criteria is met, we send the image, keyframe image, over to LLMs, so that it can be more efficient, it can be more timely respond, and potentially it can connect with more devices, because you don't need to run that all the time. So now you have the capacity of maybe getting more like photos from different cameras, or like from different sources. And in addition to that, as I mentioned, this is reference design, it's open source. We're now kind of working on, like already worked on the vision part of it, but apart from just a sensor, it's also what we call a human machine interfaces. So it has a screen right here, as you can see, it's sleeping right now because I'm not running anything. It can be a few little devices, one of the things that we, our team does when we're first designing this is that, sometimes you're at desktop and then you're sitting there for like, I don't know, when you get really into the zone, you sit there for like 3 hours, you don't move. And then this can be your little like, buddy, help buddy. But like if you see the person sitting in there for like 40 minutes, tell them, hey, get up, go to the bathroom, drink some water. It would be a fun, interactive way. And then if you're not in the room, for example, if you have a small kid, or if you have like your dog, dogs can go crazy if there's nobody at home. So what if you just have that, and then giving the prompt, you're at work, nobody's watching the dog at home. You're like, okay, tell me if my dog is chewing on my soga, or like if it's going crazy. And then whenever it does, it's able to play a sound. It'll be like, hey, stop doing that. And then the dog will be like, what's going on? But it's able to interact with the surroundings. It could be human, it could be other things. So that not only that you're able to comprehend complicated scenarios, it's able to give like it's an interface that is able to like kind of connect with the world as well. And that's pretty much what a device is. As I mentioned, now we can actually do push to talk as well. So it has a microphone. If you're looking for something that is more going towards like not only vision but also like sound, and we have extension port over here, so you can extend it out like other sensors like temperature. It could be like humidity. It could be, I don't know, like fire detection, etc. So now, like at the end of the day, you can have like a little devices that can collect multiple like sensors at the same time, and then you feed that multimodal like information over to LLMs so that it can enhance the accuracy of understanding it. Yes.
May I ask a little feedback a little bit, see if I
Absolutely.
understand your architecture?
Yes.
Okay, I think I understood what you said about function. But so there's a conversational LLM-based agent, and it's running either in a good smartphone or on your PC.
Yep.
And Wi-Fi is connected to that device. Yes, or Bluetooth?
Yeah,
Wi-Fi,
so
Bluetooth?
it's connected currently with Bluetooth with your phone. So we have an application over here.
Sure,
so you can give command, tap in anything on the
Okay.
phone, and then you can see the result
Okay.
alert on the phone, and also as well as like changing the prompt.
Okay.
But then for the Wi-Fi part, it does have Wi-Fi, and the Wi-Fi only works when it needs to connect with LLM. But the Wi-Fi can be public Wi-Fi, like right here,
Yeah,
connected with this
okay.
one, or private Wi-Fi if I'm connecting that with my laptop or my local LLM.
Okay, so I'm trying to figure out what runs where.
Yes,
That's
yes,
that's
yeah,
where
yeah,
it could
yeah.
be. I mean, so you have edge AI in the device,
Yes.
and what you've done is you're able to load down maybe YOLO based or
Yes,
yeah
that's
YOLO based computer vision deep learning recognition,
Mhm.
right? And you load YOLO networks tuned for whatever the person asked to be detected.
Yes.
Right?
Yes.
Okay. Watch for my dog, or tell me
Yes.
when my wife gets home, or whatever.
Yeah.
Okay. Okay. And so the conversation is not being done in there, even though somebody may talk through it. The audio gets transmitted over
Mhm.
Wi-Fi or Bluetooth. I don't know. So okay. So does the LLM run in the smartphone, or only in a more robust device like the
Right
PC?
now it's on a more robust
Yeah.
like infrastructure.
The latest smartphones, probably in your product plan, they actually have,
Okay, yeah.
Apple's working really hard to make it run in
Yeah.
those little babies. But,
Right.
but you need a reasonably robust PC, and
Yes.
as long as you've got one, you can. Okay, I get it.
Yeah.
So it's the PC itself has to run the LLM, but it doesn't have to look at the real-time video. That's being done with a YOLO downloaded to the
Yep.
edge device. What kind of processor runs the YOLO adequately
Great question.
in there?
So that's my guy. He knows like all about this computer vision thing. So I actually have two like MCUs, microcontrollers inside. So we have one, the camera right here. The camera module is called HIMAX, HIMAX.
Okay.
That's a Taiwan company, and then they are very specifically working on like computer vision. Like,
Yep, I've heard of
yeah.
that.
And then they're using this one is using ARM Cortex M55 and Ethos U55, which is currently like the latest computer vision solutions.
Okay.
Yep, and then we also have like a additional one, which is ESP32, like expressive S3. So that is more for connectivities both on Wi-Fi side and also on Bluetooth side. And then in a way, it can process the additional, like, for example, like the other sensors I was talking about. That will be running on the ESP32.
Okay, thank you.
What's the battery life?
So I have a small battery in here, like right here. So the battery life on devices right here, I'm actually running LLM because that's more like power consumption. That will take maybe around, I'll be solidly working for maybe like, let's say 15 to 20 minutes on these devices. But then if I'm using, this is I think it's 6,000 milliwatt like battery pack. This will be lasting for like a couple hours, and then that's like very solid. The idea of this again is a reference design. We don't design to go to market like Rabbit R1 or those kind of devices, because we know the technology is not ready. Even when we're testing with LLMs and fine tuning with these devices, it's just giving us like sometimes like weird, breakouts. But then we want to show people what is capable, and then the whole idea of combining like far edge, on edge, like tiny machine learning, what we call devices, and then LLMs.
If I want to work with you guys, so
Yes.
what is the procedure? What is the business model?
Sure.
Yeah.
So as I mentioned, this device is fully open source, so you can get into all the hardware, the designs,
The firmware.
yeah, firmware. You can change anything. Right now, we're just selling these devices on Kickstarter. Actually, it's $89 with everything, with every 15 minutes of calling out to LLMs. But then if you want to do like, faster, it will be a little bit more expensive, but I think it's in the range of like less than $10 for like monthly prescriptions. And then I think for the first, at least for the first month is free. And then the idea is that for people who's interested in this, they bought one home, played around with it, they some way, like during the whole process, they trigger something. But oh, you know what? I can build new devices using certain features and then go to market with it. Or they can be a application that is really neat for this device. I can use another screen, or I can add on something, and then they'll come back to us and hey, like I really like the idea. I want to use this whole hardware pieces. Can you help me do it? Again, our company focuses a lot on hardware. So we can help them like build their own POC, like samples. We can instruct them on how to build their own devices or proof of concept with the parts of it, and we can help them build the actual thing and go to market with it. Yeah, so that's basically the model. Sorry.
Yeah. Are there specific use cases that you support, or is this like say, like for example, the Rabbit or the other devices that were, which is basically like you can ask everything under the sun, like what's the weather today, how many calories does this cup of almonds have? So are there specific use cases that you support? Or?
So right now we're thinking, because I think one of the reasons that when AI King and then Rabbit R1 come out, and then everybody's excited about when they first got the devices, we're like, oh, this is not working. But one way is like, yeah, like I think that was a great feature. The application is gonna come out like as LLM progress. But then the other thing is that because you have to personally wear them and go everywhere, the overall environment is very complicated. Way more complicated than what LLM is able to take on right now. So the ideal application for these devices is that you can just place that, like mount it in a wall, like in a wall, or like place it on your desktop to have like a somewhat like more simple scenarios. And what it does at the end of the day is looking for abnormal behaviors. So like it could be an object showcasing here, it could be something going wrong, or you can just tell like, let me know if there's something wrong here.
So it doesn't work on a moving vehicle,
Exactly.
for example. It's got to have a reasonably stable background.
Yeah.
And that's how you get the computation down to
Absolutely,
where
absolutely.
it's not too crazy.
Yes, and
Okay.
then you can use that as your, kind of integrate that into your like smart home applications. Say one of the applications, or let's say like we have our receptionist, very busy receptionist. She's taking on so many works, but then whenever if she's like out of the desk, like go to the bathroom or handle something else, when the guest enters, they don't know where to go. Like that's like you don't really need to have like one person always there. you can have this little guy right there. Like if you see a person tell, hey, please take a seat, you know, someone will come be with you. And then with the receptionist, they will have their own phone, like applications. They'll have alert on their phone, like, hey, someone is there, go over there. And then one of the other applications we're thinking it will be like smart retail applications. Like you go to a retail store. I recently like saw this article about like in average, like Americans especially, because like we have like large supermarkets. Average trip to the supermarket for every single like object you're trying to purchase on your shopping list, it takes 30 to 40 minutes. That's way too much for if I know already what I'm trying to get, and then I still walk through the door, spends 30 plus minutes to find everything on the object. But imagine if I just have these things like in around here, I'd be like, hey, I'm looking for this. I'd be like, okay, it's aisle 7, and then on the top shelf. So it would be more like time, like, you know, efficient in a way. And the other thing that potentially we're looking also is for like a smart, more like a simple applications for like elderly care, especially people that is alone in their home sometimes. If you're trying to like see if they're falling or they're like something's happening, and then if they need to call for help. So we're trying to make that process like easier for people to be able to get immediate alert and help them with it. So that's so far what we think that could potentially happen. But then the only great part of that is open source is that we have people from all over the world coming up with new ideas every single day. So yeah.
So yeah, a couple of things. One is like, so the application is mostly not towards like the personal assistant, which like Rabbit and others who are sort of focusing on, which got criticism that why you can just do it in your mobile phone and you don't need a personal assistant device.
Yes.
This is mostly a static thing which will be monitoring, so more like a advanced like home automation or monitoring system, right?
Exactly.
So
sorry. Yeah,
I was just saying that you don't then need a battery, right? Because it's static, you can just like have a plug. So you don't problems with power basically go away.
You do have like a plug, you can plug it in and it can always work. But then in the case of like we're just building this because it has like the capability of running low power. So if I have a very simple task, I don't need to be there. And then a lot of times, for example, like if we're talking about like openly public space, like automations, they don't really have the ability, they don't have power everywhere. And then they're old buildings, you have to talk to so many people to kind of being able to like have like cables right there for charges. So this is for like more shorter time, but then like, you know, you're able to place them everywhere. And then another thing when you mentioning about the other two devices, so that devices, it comes with humans. It is, you know, next to you. For this, it's designed for when people's not there to like remotely understand what's going on.
So two other questions. One is, you mentioned that there's a subscription model to like do a call to an LLM which can take a few minutes or whatever the latency could be, few seconds. Is it possible to do like a call towards an LLM which I am hosting myself on some remote machine?
So if you're running
and not have a subscription model, just pay for it once?
Yes, absolutely. So right now it's just kind of like experiment. Again, we don't rely on people to buy this and use this right now immediately. If you are able to run your local LLMs, or if you have your own, or you're subscribed to like OpenAI or something, you can connect with your own account. And then if you have like, for example, like Llama, so it now supports like, I think Lava and Llama models on it, and then you can just call out to your own computer and it doesn't cost anything.
And then finally, you mentioned that it can take in other, like let's say sensor parameters as well, right? Like the humidity, temperature, and other IoT sensors, right? How do you see that being used in the decision making? As in, like, is the ultimate idea for those temperature readings to go inside an LLM call and then LLM to orchestrate what the output should be, or is that can that be a custom system, just a simple logic based? Because you don't need an LLM to decide whether temperature is above 30 degrees or not.
Yeah. So for these dumber sensors, what we call, what we're trying to do is that it will kind of service as an additional like modality or like you know, data. So if I'm just using the cameras or if I'm just using sound, right now the issue when it comes to real world applications is that it falls along. It's like sometimes when they see that, but it's not really the true scenario. So we're adding more like, you know, I can detect like maybe like camera, like images or sound, and also like other factors. And then when I'm feeding all this data, and then I have a 10 step too. So I'm feeding not only one parameters, but maybe 3 or 4 or 5 to LLMs. And then I can prompt LLMs to be like, okay, so this is what you're looking for. Check all the boxes before you send me an alert. So that will be the kind of idea scenario that we're thinking.
This is like Arduino of LLMs
Exactly.
or like
Yeah.
Raspberry Pi.
Yeah. So one of the things that we're trying to do is that this is what made Arduino, like Raspberry Pi developers, to very quickly add AI onto their thing. Like you don't need to do anything, put it on there. It's supported like natively. You can just connect it with Arduino right now, and then you push the top. You can text. You can interact with it. It's already adding LLM capabilities onto those boards.
Two things. So, did I read it correctly? Your goal was to raise $10,000.
It is, but then
You got 70. Yeah.
yeah. Well, the idea, honestly, like we don't. The goal is just there.
Okay.
Because we already manufactured those. Like we're gonna ship them out anyways. So we just want to make sure that people like are confident that we will be making sure shipping those devices to them. But we're just putting out here in general, trying to introduce this to non-developer people, because for developers like Arduino, like they will know that they will get this. Yeah.
And then have you thought about partnering? You said you're in San Antonio. Is that
I'm actually in Austin.
okay, perfect. So the CAP-COG region is the 10-county region that surrounds Austin, and they have a program that focuses on like essentially aging population. So I'd highly recommend reaching out to
Right.
them. I don't have a contact. I just figured.
What's the name?
The CAP-COG?
CAPCOG?
Yeah.
Okay.
CAPCOG.
Gotcha.
Yeah.
Yeah. Thank you so much. I will definitely reach out to them. Thank you.
So, just a quick question. So is this technically considered digital twin?
Not really.
No?
You can just kind of think of it as a way of a combination of a smart sensor with a ability to interact with its physical surroundings. Yeah. Or it can contribute to the digital things, because I get feeding in the data, making sure, you know, for example, like the camera's capturing what is like the actual scenarios, to kind of like prove it, you know. Yeah, that's
In the physical security world, there's a lot of products already that have this sort of thing, but I can see what you've done here is you're driving the cost down,
Yes.
first of all,
Yes.
and you're making it more friendly,
Yep.
and you're driving the power down,
Yep.
so you can plug it in and not worry about the battery, charge it up once a week or something. I don't know how you're gonna end up. But in the professional physical security world, the concept is more or less proven. It's just not as accessible as
Yes.
you're making it.
Yes. Yes.
Okay.
Absolutely. So what again? This is what we think can be like very innovative. So it takes a lot of explanations right now when we're going to like conferences and show that to people like what does it do. It's not a one-word thing. It's like if I'm saying like, okay, we're building a physical AI agent, you're like, what is that? So I have to give them like a whole speech about what is it capable to do. But then again, we think that this could be something that is changing or being able to accomplish and go to physical like real applications. But then we just want to introduce this idea and let people know, okay, that's another path to those kind of solutions.
Does it run 24/7 like while it's active, or is there a triggering event, like for example when something changes when it goes?
Yeah.
So how does it like say like is it running all the time capturing images every single at a regular cadence, or how does it work?
Yes. So for example, I'll show later on because this is too far away from you guys. But for example, like I have on-device detections. So as I mentioned, the object detection is running fully on these devices. So yeah, I'm doing like, hold on. Oh, there we go. So yeah, I'm doing this. It's doing almost real time.
Got it.
Right, like a couple minutes, it's able to do like a detection. So that's like very fast, and then fully running on it, so that's almost real time. But it's again simple task. If I'm connecting to LLMs based on how like if I'm just sending every single photo over, it would take maybe around like say right now the latest one is every 1 minute. If I do capture like the object first, stop. If I do capture the images, I'm sending that to LLMs like every 1 minute to have more complex, like analyzations. The reason we didn't make it shorter is just because it takes time for LLMs to process the data and then also give back that. If you keep on sending that new data, then in this case, like LLM is still processing the photo that's like a couple seconds before, so it's not really accurate in that way. But yeah, the latest one is 1 minute, and then you can just change that. You can adjust that right now, like how often do you want that to be sent to an LLM? Yeah.
So is with their, but do you all use like a cache instead, like to like get information where it's like relevant, or is that like not used at all? Since like the things that can happen are so different.
Yeah.
So like, is that not used at all? Is there, or do you have like applications where you sometimes might use like a cache?
Right now we're not using anything at all. So I think we're not the AI algorithm, like like LM software person in a way. Like it's not. We're trying to do it, but it's very complicated. The best thing we can do on our end is to fine tune like the current general models and making sure that they're understanding what architecture is. That's the job we need to do, and fine tuning that for our devices. That's so far what we're able to do. But then, of course, like as it progress, and then hopefully some other developers have a more specific applications. They already fine tuned, say, like LLM, just for this application. Then we potentially will be able to add them to that.
So is the information stored, like is the previous encounters, like your dog, I don't know, was yelling or barking like 2 days ago, is that stored somewhere else too, or?
It depends. So you can store that. So right now, for example, we're running images. So whenever that is being captured, you can store that in cloud, and then you can choose not to either. So like same thing, if the dog is barking, then you can kind of like store that data into the cloud system, and then you can check that later on. So that will be part of the history session.
Nice.
All right, give a round of applause for that. All right, take 5 minutes break, go to restroom or whatever, and then what I want you to do is like come here, line up based on your experience building AI. If you think you have, I don't know, 50 years experience building AI, line up at the front. And if you think you have no experience building AI, line up at the back. And I want some reference points. So who do you think here has the highest amount of experience building with AI?
Do we get to nominate somebody else? Like, what do you mean? Or just
No, like just if you think you have a very long experience, just raise your hand. Yeah. Like just throw some numbers. So I have around 8 years experience building with AI. So yeah, that's my reference point. Anyone else?
I'm at 3.
3, okay, and then 5. Yeah. So yeah, based on that you can line up, and then you can use these guys.
AI is a very broad term.
Yeah.
What they call AI when I started decades ago isn't quite the same as what you guys have been working
everything
on. So my adds up pretty good, but some of it was super primitive from what you guys were
defining.
Yeah, machine learning, statistical like analysis also counts, data science also counts. Yeah.
Perceptrons?
Yeah.
I'm actually not old.
But you can definitely use me as a reference point. 8 years, 5, 3.
I'd call mine in the middle.
Yeah. I think that
years,
would
but
help. And yeah, based on that, you guys can line up here, and yeah, feel free to take a 5-minute break.
All right.
Yeah.
So what do we do
After the lineup, we'll just move around the room in like small breakout groups, and then have a networking session.
Have you got a card? Now, I have to email a young lady.
Oh yeah. So let's see where.
I don't know if she's a marketing person.
I keep thinking you was on warm at night.
I am on LinkedIn, but you can just take my card and she she was, I don't know if she's really doing it.
Yeah.
Other than going with
She was very interested in starting a high tech.
No, I just didn't wanna like
for older people. What are you doing? One of those
Oh, yeah, thank you.
But it's quite good. And I had a conversation with him a year ago, and
so one thing I'm trying to think.
I knew a lot about what was available, and it was really helping her get her head around it. And even pointing her to a very high-end video device, company that was doing it. It was a new product line a year ago. But they didn't have anything. And my pitch for her was, because I also, my mother-in-law is 90-something, and all of her children were all, so what, we gotta get her a device to look after her, and so the point is, the people who need it,
since these are healthcare
do
clients,
not want to deal with
requires
these
us to customize it.
Yep.
So we
and even the ones like me, if I get old enough to
we are trying to customize all the use cases. And essentially, like when you're concerned,
even if I know how to handle it, I really don't want.
You're building it.
Exactly.
Yeah, building it.
That's-
So
And
it
then
has
we
to
try
be
to
key.
see if this
And
product
this has some potential.
we also have like our own level of
I
expertise.
actually told this kid to get drones,
Working
and
healthcare,
they
like,
follow
for
it,
right?
they don't have to
He has the network, he has the network, he has the technical,
well,
the medical jobs and all that. So we don't necessarily
no,
know.
I actually thought this was brainstorming, right? Was,
So who's
it's a drone, it's just,
So we
the drones
make sure that we
look
listen to their
around.
problems,
Right.
but then when
And
we
the
build it,
drone
we build it
can
on our own.
hover.
Then we give it to them, then
So
there's this
that
code
it's
development that
still
happens, and then once we get to
in the
the
environment,
confidence that okay,
come
this
over
is
the room,
like, so this one
hold
was like
still,
immature
have
version
that
of
thing,
all the
you know,
different
look
products.
around.
We are like 6 level co-pilots.
Is grandma in there?
Yeah.
No.
And
Where'd
now
she
that I
go?
think
Oh, she's
we
on
want to be
the
a,
floor.
so
Yeah.
the way we look at our business, we are the
Yeah.
orchestration
So
layer
the,
that comes together.
there's
So
a lot
the
of
reason
things
why we
like
say
that.
that is,
If
there are data scientists in
there's a
healthcare,
lot of drones
they don't know how to make, like say, use
makers
an OpenAI API.
You put that thing on the drone,
Especially with healthcare
go.
products, just in terms of the curve of the industries which are the most, like
As
the
long as
progressive
the
and
drone
technology
can hold
compared
pretty
to
darn
the
still,
most
you know what I'm saying?
healthcare
Sorry.
will be on the latter end, especially when it comes to
So there's a lot of potential for that.
So we want to give them the toolkit to build these models, not building models, building solutions. And that's why we want to be a
robot,
especially in
and it just stops and then looks.
Yeah, and then it has a phase of
build
like,
them
hey, how's it going
Right.
today? And then the other thing where the
What's the
reason we
reaction
want to
from like the
kind of
nurses, the
introduce
people on the ground who are
pair
getting
is
the
that
results? Like, what's their take on it?
a lot of
and
times
I
when
mean,
you have
that's a
people
good question
coming to
because
us like,
so
we want to build something
like
like
a couple of things there.
interactive just for
Firstly, yeah,
for like
you know, they are
emotional comfort.
Yeah,
Like,
no,
yeah,
like
those people like they just want people to like something to touch up.
as I said,
Right.
like
So what if you took something that is like of course bigger than this and they can
so they
chat
are
with
okay
them,
with
like, hey grandma, how's your
there might be
day?
so the
Yes.
Blah
So we're
blah blah,
selling the
doing all the
work
chatting
rather
to have
than
this
selling
emotional
the
attachment,
Yes.
and then it's not something technical more. Like it's just some like a companion.
Yes.
And then
But
but
obviously,
they,
you know,
the
especially
only
when
thing they
these huge
don't
organizations
now or
like,
don't
where somebody's
pay attention to is that apart from
like
chatting,
listing on the company,
it does, you know, help monitor if she's okay. And then if
yeah,
she's
it's
not,
not
then,
like say
you know, alerts can be sent.
Well,
because it's
actually,
overwhelmingly positive thing.
I was really.
No AI development.
Yeah, that's right. So that's why, like, there'll be some commonality.
Yeah. Right?
Spectrums,
Okay.
yeah, so that's ideal,
Where you could train that, a YOLO,
well, my wife
could
works
be
in
trained, for
healthcare.
example, to
Yeah.
find medicine.
Yes.
And
I was just curious if the Canadians reaction to it was in terms of like, is it
So right now,
I saw those demos last night. I
Okay.
don't
faster
know.
or is it feel like
Yeah.
that's
Yeah.
more
Yeah.
difficult?
Oh,
They
nice.
they love our
Yeah.
products sometimes
Right now,
because
they say
Oh,
that
nice.
it's
doing
part
some
of
of
the
the mundane
content
tasks.
What about
So
work?
when we are trying to automate this administrative
Yeah.
work,
So, yeah.
That's
so
right.
we have-
Yeah, device,
we
yeah,
have
what
like
it can
a-
achieve with
like,
the-
yeah,
it helps them like
the price
it's
to-
like-
Right.
They
They
want
want
to
it.
Yeah.
So they won't satisfy that. It's something that they care. So they're not focusing on the dull tasks.
Some other-
We focus
some
on
other
like
vendors
more
or this,
intensive, very request work where they
turn
feel
that
like
way,
they need
and
something.
we're,
Guys,
somewhere else,
please
or
line up.
other
So it does depend on
exactly
you know,
with
who you
the
are.
medicine ball, because they can,
Yes, that's exactly
Right?
right. I'm
Please
exactly
let-
where we're, yeah. No, that's exactly right. I think I'm probably in the middle here somewhere.
Yeah, look, I'm in the back, no AI.
You have to have a scale on the floor, I remind you.
Yeah. I mean, I gave the reference points, so 5,
Yeah,
8,
no, that's
like,
great, that's cool.
the product.
yeah, and,
Well,
I'm
it's
gonna
started
say,
with just one to like one
a lot of computer vision, but
reading you.
the part that really turns, what it really, most of the people call
So
computer
we
vision
started to
AI,
develop
so I
this
probably
in,
have,
March.
something on the order of, like 10 or 12 on
Yeah,
that,
so then
but,
please.
not all vision
And then
of
that's
this
the
modern,
good
let
part
me
of
put
open
it that
source,
way.
right? We don't need like
Yeah.
perfect devices to get out there, you just
Same,
send
I
the
mean,
message,
well, I mean,
so.
I
Now
got
we're like, is it
15 years
okay,
ago,
it's good enough, it tells the story.
Well, there you
Yeah,
go,
yeah,
see,
it's-
that's right.
So if you call computer vision, for sure, I've got
Yeah,
10 years.
so
That's
I'm
a branch of AI.
You had out in the wild,
it's,
like people using these devices.
Yeah.
Now we
So
have
like the
around, I
context
think
key is, like, all
almost
these, like,
100 of
computer vision
those,
companies
cause we
I've been
sent out to a
applying
lot of
yourself
our
for a
alpha
while.
testers to
Yeah.
kind of play around with it,
But
yeah,
now
so.
AI
What are the most popular use cases you see?
They got
Right now,
better
since
with
there
the
are
big
gigs
deep
and then
networks.
developers,
Yeah,
they
yeah,
just
so
make
now I
it
can
more
use
like a
any
fun
sensor
game.
that I want.
Or, yeah, like a
Proprietary
companion
ones.
thing.
So,
And you'd be like, oh, drink water, or like, oh, like do this, and then,
What
one
kind of
thing
computer
very
vision work
funny
are you
or
doing? What's
interesting
your-
thing, and we're
Well,
trying to
so,
see,
and it's,
open source is something else,
Okay,
but we
yeah,
have a
yeah.
guy in
Yeah.
New York,
I really
and he's
don't
super
know.
Okay, so, yeah, I'll just, ask everyone
What they used to
now
call machine vision.
to break out into
Like
groups of
stream
3.
our program.
now,
So what
And
I
then
want to do
what
is
we'll
that
do next
he's connected to
is,
LLMs.
we'll like
You can
introduce
help with
everyone,
it, and then
one by
kind of,
one.
okay, I got stuck
Oh,
in here,
yeah.
break the program,
So you're going round,
and let
round,
me
and-
know what I do.
Yeah, go ahead,
So
Ronald.
suppose
So
that
for
this
now,
is working on that, but it's
yeah,
gonna take
just
a
break
while.
out into groups of 3.
That's a great idea.
Yeah,
Yeah, you can pass the
It's like
message.
very focused on
We should
streaming.
connect.
So it'd be around
Yeah,
the
I
world,
did.
because he can't look everywhere.
Yeah, I think that.
Yeah, so, and then you can have like a station on
You probably have some
just point out to, like, look at this, and like, maybe potentially, you can develop these
Well,
like
either way.
push buttons, to not push top, but take a photo, maybe, take a photo, like, and then you send it over, tell me what's going on with the code, like
Yeah,
something like
sure.
this.
Like, what do you do? Sure.
Yeah, I am in computer vision too.
Okay, what kind of
So
stuff?
I currently work as a machine learning engineer.
Sure.
He has to line up,
I
now
saw
what?
your, how are things going? I was still figuring, maybe I have to convince someone to hire the other guy. And I asked him, when you guys brought that whole thing in,
What did he say? You're in the beta, okay.
So what are y'all tinkering on?
Because you take these screens and find
like they have to make us, yeah,
They don't care about it. Nobody's gonna hire one of these don't worry about it, just help one way. So, but I went there and
like they have phase 1, phase 2, phase 3 is all up and running. We primarily use
I'm starting an
information
AI
from phase 1
company,
and phase 2.
but I'm not really technical, I'm not really technical, right?
That's where like
teaching
the
people
data
how to
science
learn
is where
language
explored
and
data
jobs,
science
to
comes
teaching
from.
financial success or advice.
Mike, something.
That's cool.
And I got that from being in the Uber when they
How do you
were
have
saying
you opened up your big,
because like,
facility?
I'm learning,
That was a nice
especially
company.
like back then,
Obviously,
you know,
yeah,
like
honestly,
the tips, and then just learning the phrase
that
and
time,
days from your own interaction, which might be different than yours, might be different than yours.
relatively
And you can
benign
review it,
odd way
you can
me and make sure how.
it's meant to be like, you know, 10 minutes.
Let's run
You
taxes
can do it in
around
your
that.
brain.
And it takes the data out.
Yeah, it's like context specific learning. Like, alright, here's most people learn.
Well, I say embrace it because honestly, I've lived in other countries and I've learned languages without being studying English, which is why they're doing what they're doing. But if they learn English, just the phrases, they're not going to know how to conversate English. It's just the phrases they need in context. They can recognize what you're saying in context. Or slowly build. So instead of learning the whole language, which is daunting and overwhelming, and you're like, maybe I didn't like school, so this seems like horrible. But learning a phrase means you see your income go up because Uber has APIs, including earnings. And if you see your earnings go up and you start using these phrases, it's motivating. Yeah, that's cool. Everybody wants to make more money.
They what about you? Yeah, well, first of all, we were working on AI tools for data scientists. So like better versions of Jupyter Notebook and Google AI tools and all that to like make things better. But I just left that company and now I'm looking at AI assisted research and like collaboration. It's more that I want to do. But it's very much like I have a ton of questions and random ideas and much less less than like actually acknowledging my idea. It's very much a secret stage.
How do you establish reliability? Not reliability in the sense that we have these test cases and we're working. Reliability in a new use.
Oh yeah?
Because you might have, I don't know, like if you're working in cardiac stress, for example, and then let's say your data set ended up being more cardiology, and now you're moving into a new space. It was like, how do you, with a new insurance provider, how do you establish that? Or maybe you were working with diseases and now you move to accidents or something like that.
I mean, it's kind of
there's a data
always have a
you can't have data from this.
I read into all the time, like, come across like companies and libraries and different things, and like, why is this interesting? Why, like, everything I was hacking on the street was like,
You can have a Scrum extension.
like, you hit key, when it was a website, pops up a thing, and you just ramble at it. I'm like, oh, this is,
I see. So it's
whatever you think about this company, is like, think I'm concerned about this, but it points the whole thing, scrapes the whole page, transcribes and embeds the whole thing, and stores it in like a vector in the text or interface. You can search for it later. What was a healthcare company that I was looking at a couple weeks ago that was doing something around this? If you don't get all the terms right, it can like resurface that for you. Like, here's the site, here's what it does,
that's the thing
and like, here's kind of roughly what you thought about it.
We have explored like a bunch of different use cases for
It's super rough. Like, the pieces
collecting
are
information from different clinical trials and all of that. The problem comes in because the domain specificity is the problem, right? Like, you move from one kind of a trial to the other kind of trial, not face to face. It's like this is like trials in cardio and then trials in neuro. This rack system will not work. So
fundamentally, I think what happens is
an end user doesn't care. They're like, I want it to work.
One is in your lab, you need to have a strong library of skill models, things like embedding models, technical models, need to be adaptable to the business. So you provide the APIs for the next final output given at the same APIs. There's enough context for it, so that way I think if you have library of models and you can test which one
It's so annoying. It's so fast.
if y'all call it business,
I always like, I don't even listen anymore. It's like 0, 9, right? I'm gonna talk to a real person.
But yeah, so I mean, it's definitely something that I think you're able to get.
it's not that our data is working well, like a lot of us. Well, maybe I'll still have both. Because it's fundamentally our data have knowledge about the that's one more
highly specialized data.
Package all this in a way that is palatable for customers. So the thing is, yes, you can but it also has data streams in the structure. So that's why we're like all of the
I don't know
not the company, like the team more
this and that. They have the knowledge because it's on their but if they don't have the exact, like it's just, I feel like they're ready, right? They're like, oh, this is about time, but you don't really know how they know that, and then they don't even know how to know that, right? Years of experience. So now we're like,
somebody like
we collect all the data.
So that's where it becomes
Yes,
there's an LLM that's
that's not your mode.
this is
Yeah,
like
that's
that
expertise
situation.
is
Right,
solving it
that's
out,
just
right?
solving it out, and also making sure like
okay, so if you have all these data, so in that this literally just like acronyms or like
that you have for each of these.
that actually can be something that can help you solve
Yes,
problems.
but
it's not a one size fits all.
Relying on
This transferable
like
programs.
Not this transfer. Like the technology is
like, I can like,
So,
look at this
you
plan,
can't
I
like
know
say,
what
just
exactly
say
what
like,
it is.
I have this
Yes,
like
more
business.
scientific.
So that's why you have this whole concept of agents because when it's like in major, you don't even need to
And then
specify
again,
especially problems that
world
and solving them independently. So somebody just wants like say summarization.
for you based on your
Part of
resume.
soil, that part of
Yeah,
soil.
because it's such a big company.
And
And also they don't know all this stuff. Like,
Oh,
they-
yeah.
they
Yeah.
don't have
Pretty
any-
clear you were committed. I saw the big
So,
new
yes,
facility.
it's like what is it for them? Rather than them knowing how exactly to use open
I don't know, 50 or 100, and this year,
That's all it's for.
really going.
Yeah, yeah, so we,
More
we,
accurate.
So you at the end of the day give them an API.
In a way,
Because you are
less
managing the
expensive.
back end. And
Yeah,
then
that
their
is
front end
cool.
things
So,
is like
yeah,
connected
no,
to
it's
the
basically impossible for them to replace the other firms. So whatever you said in that year,
So like when you
are you based primarily on like the whole team is based
They don't have to go
amazing team is yeah, it's
What
in and
impressed
outside
me
the
was,
but yeah,
when I got the
it's
tour
only
of
leadership
the
teams.
trucks,
It's kind of like decision making.
That's cool. He's working with. But it was like, because I was talking, and I said, why do you have so
Oh,
many?
yeah,
people?" They go, well, we never know, and we got an overlap, and I'm like, oh, to like, and then I thought, it's probably, it's like probably $150,000 truck, so I guess, doesn't matter if you got 3 more
yeah,
camps,
so,
you know, look
yeah,
at the.
you're talking like 150 to 200K, just price.
And everybody takes admin and everybody hates their
So autonomous
admin.
trucks, the price
I
point
know,
goes
I know, and I'm like that one person that really likes.
Yeah, that makes sense.
Yeah.
So you don't.
Higher using
I've master's
AI.
degree in higher education administration, I like really like
trucks.
Somebody's gotta be that person. And at least I'm like excited about it, right?
Wow, I didn't know, I mean, that's an easy job, that's just a fine.
Do what?
Yeah.
There's just so much like creativity that you can still bring to the table that yes,
Yeah,
you
yeah.
can essentially
I see what you mean.
like there's
and like
a strategy behind
business
what you're
model
doing,
around, like,
how
building
you're
these
doing it,
up,
the people that you have,
the
or the less you have.
Okay. It's like a railroad laid on top of the interstate.
Yeah,
Very interesting. You know, I
Okay,
like.
well, have fun with the negotiation process.
Interesting competitors. I'm trying to remember
Or if
the
they
name of it.
decline, how are you gonna tell a robot to be like,
Yeah, that's a Chinese
Come
company.
back.
Right.
Get out of there, and then
Oh, okay.
hire them.
Yeah.
Right.
So one time I was thinking of the guys from Scandinavia that are trying to do the electrical
reject
ones.
you to one, and then you get them?
Trying to
No
remember.
way,
It's
no way.
Enride. EIN.
So at least one recruiter on that, always.
And what they're doing, EI and RIDE, and I've actually met their North American guy, because some investors in this town invited me to some meeting where he
No,
was
it's
one of
not.
the big investors. And
We
they're
get
doing
lined
it.
up.
Right, very
So
much
we
what you're
accomplished that
talking
much.
about.
Yep.
But it's
Without
all
AI.
electric to make it clean.
That's part of the
Yeah.
problem,
What about
why
the
you tell us what to do
Yeah.
next.
What do you use for actually
It's
doing
not gonna
it?
help
Are you
you
doing like
we go to the
judge
west.
or
But,
like
but
matching
when
the
you're moving
criteria
freight
that
through
you're
the
expected
northeast.
to
So
I mean, like once we go into production, how
Um,
Yeah, you want to change something about the prompt, how you do it better, worse, in any case, it's like.
we don't use any out of the box like say solutions. I'm not sure about LLM judge.
Just the technique, and if you give it the expected answer and the output, and you say like, in these critical aspects, where is it better?
Yeah.
But it's, sometimes it's like the blind leading the blind.
Yeah. So because we just take like 5% of the entire volume data set, so we don't. I think again, I'm not really sure about the evaluation framework because we do have like a pipeline where it does that, and it does. I think like what you're saying, where you do a prompt, the Q&A pairs, and the pairs of what exactly should be expected, what exactly is included, and so on. But I'm not really sure about. Like I can get back to you.
I'm just curious, because I gotta imagine 55% of kind of all things that are run, like after a couple weeks or months, you got a pretty good forecast. So like,
You have to,
you hear the expected output, but because the thing you're generating is very fuzzy, at least with the summary, it's like, is this summary better or worse? Like,
I mean, like again, I'll have to check with that team how they do it. But yeah, essentially, yeah, there's a level of we pass both of these outputs and see what exactly are the critical differences, and you also give it specific attention to certain portions that you want to focus on. But again, I'm not really like the evaluation framework is something that another team was taking care of, so I don't like know the specifics.
that's fair. It's just top of mind for me because I was hacking on something similar. It's like self-generation. Like, is this better or worse?
So-
Is there at least one particular case?
But
Is it better in aggregate?
so how like can you walk me through the use case? Like, for example, where exactly are you facing this?
When I
Well,
finish talking to him.
Again, it doesn't have to be industry specific.
That's what I
so-
feel.
Yeah, no. it's weird because it's not. I did it twice in the last month or so. So one of these I was doing sort of where it was like, so the tool I was working on was this like tool for data scientists. AI that helps you generate code, SQL Python, and you want to know like, is the code is generating better code? So you have a bunch of examples where you're like, okay, here's the problem, and here is the correct solution. There's a lot of ways to write correct SQL.
There's no problem with I'm the other
I'm also doing something similar where it's like I'm basically trying to do research and like summarize that research. Like, okay, I looked at where's the company, a whole homepage, a bunch of notes on it, like, what do I actually think about this? Like a paragraph. What do I think about this?
So this is what I mean, this was mostly done by a data science team, but this is my understanding. We do create this set called the golden set. Again, specifically to this use case where we know this exactly is the exact how the like the input is and how the output is. So you have these pairs basically how the input is looking like and how the output is looking like, and you have this set. And I think what they essentially did was like see how the model is performing against this golden set and against the like the new faxes that are coming, like 5,000 faxes. So, but then again, like I think I'm not like expert there, so I might have to understand the problem bit. But I get what they're saying, but I just don't know. Like you're saying, like, for example, I just get a result now. How do I judge whether it's good or not? It requires you to establish certain metrics, saying these are the things that I'm looking at. But again, I haven't thought about it.
I mean, fair. I think this is kind of the cutting edge for a lot of these things. I either build it with you, they're building an application, and they're like, how do we know if it's getting better or worse? Or there's like, okay, we're trying to build tools specifically for this. Like, I don't know the difference.
But there are a lot of players who know something like this. I don't know because this one is like say a bag based what you're talking about. Yours is LLM generation based, right?
OpenAI, if you're curious about references, OpenAI, like open source, their eval framework.
Oh, okay.
There's a lot of tests in there that are like, it kind of runs the gamut from the answer this math question to like, tell me a funny joke. And I need to grade, is this joke funnier than the last joke?
So they did release their evaluation.
Some of them are very deterministic, where it's like, look, here's the answer to that problem. Some of them are much more sophisticated, use more LLM grading, where they're like, here's the criteria for a nice joke. Let's break it down. This is like 6 aspects. And I want you to basically think through and grade how well you do all this.
Exactly. So there is an aspect of say having the right KPIs to look at, like say or metrics to look at. And these are subjective metrics which the LLM has to decide or not decide on its own, which you need to explain to another LLM, which is what something like grounding, but not exactly grounding. Basically you have the outputs come in and then you send that output to another LLM for it to
It's just like, at least I run into problems where like, because the LLMs are such competent liars, they often generate very convincing sounding on why the wrong answer is actually right.
More than competent liars, I feel like they're very playable. So if you say something, no, this is right, and then it's like, they quickly turn their thing. And I've never had an LLM, like, any of these open source models are like, say, OpenAI, vehemently disagree with me, saying like, this is absolutely wrong. It's just that it's not quite right. Oh, maybe it is, and something like that. It tries to be very agreeable as whatever. But I've never, I don't know, I have to take the words. But we don't do a lot of generation. That's why I'm not able to give you a very specific answer. We definitely do a lot of RAG, and then the generation that we do is also confined to the data that we provide. So
for the specific client. Right. I mean, that's part of the follow-up question. It's like, I assume that whatever eval system you come up with, it is going to be different for each different client. And you might want to evolve within the process.
Exactly.
Like, okay, like in case where it got it really wrong, like give me the right answer, help me understand why it got it wrong.
Yeah, so that's how we came up with our confidence score metrics, and where they told us that okay, if you this is like the type of response that you generate, then you flag it as say something that's like low confidence. Like we involve them in the process.
Do you have any I would that I have not had great success with like having the model on its answers.
I guess we at least like in production we run where we do so
Does that say like on scale of 1 to 10 or something?
No, it's right now just low confidence, high confidence. Low, high.
Not like that.
But then I think the thing is because we have like say we involved in every single step, not every single step, at least like the final step. So the owners are like say making sure that the decisioning is still on their end. So it does become an aspect of them say correcting what we're trying to do rather than entirely relying on what we're doing. Because I don't think we can at least I've never seen a single process where the AI-based model can completely do it on its own without taking risks.
No, in the dynamic sense, it's super so we generate a SQL query. I give it to a data scientist. It's like, hey, just answer the question that I asked. And they'll look at it and be like, well, I know your schema, I know SQL really well. Like, this is bullshit. Like, this is wrong. You kind of have the wrong table to use. This model doesn't do what it is acting like it does.
I never saw it before.
I give it to someone who is like really competent and show them the output, and they're like, oh, this is so great. I don't know SQL that well, I'm not super familiar. I wouldn't have been, if I just looked at SQL, I wouldn't have been sure that it's right. Because it wrote me this like explanation of what it did and why. I'm like, I feel better about it. I'm like, well, damn it, it's wrong.
It does pass the. I mean, if there's an expert or a professional taking a look at it, they can smell the bullshit easily. That's something that we've also seen.
Presumably, like we all become complacent with that. I mean, you see this like self-driving cars. It's like sure, it is technically humans over it, but there are a lot of humans that pull themselves out of the loop. And like it gets easy, right?
It's interesting that you say that because maybe we just it is a real problem.
I mean, you gotta imagine you've got a year down the line, and this thing has been generating the right summaries and time, like it's that's critical.
What do you need to worry about is
failing, like everyone's gonna do that.
What do you need to worry about is something like this, where it's like change is very imperceptible over like a defined period, but then over a longer period you see that it's actually pretty random, which I don't think we've encountered yet because we our data science team is pretty much involved with them. They almost work with smart teams.
Sure, it gets super amazing.
So the long story short, yes, you can have production grade systems, but then you need like constant iteration and not iteration, constant. You need a dedicated team which will be evaluating the outputs at a regular cadence. You can't like have a production grade solution just out of the wild and just wash your hands.
Yeah, totally. And you productionize the fact that like, so you have some data science on the team, you're like, I want to make this change to the model. You need to productionize the process. How do you validate?
How does it not mess up what's under the
Have you ever heard of watch?
I mean, I personally, my team keeps talking about it on Slack.
I mean, I think it was like relatively recent news, but it was cool. Like 30% reduction in like unattended deaths.
So I mean, again, I've heard of it. It's search on Slack what they talk about. So are you in the data? Are you data engineer?
I'm a full stack engineer. I've done a lot of stuff at a bunch of different startups over the years. But I just left them. I started tinkering on my own thing.
But
I think it's a good time to show up and like,
the Spanish contract, it has to be
it's kind of wild. So I was thinking about some of this stuff a year ago, using it's wild doing the same projects a year later, and it's changing, like upgrading the model. And all this stuff that I was like, oh, I gotta like build an algorithm to figure out how to like separate these data. I'm like, no, it's so much better.
I think initially when we were like a year ago, a good portion of our code was around chain of thought, chain of thought reasoning, because it required us to make sure that we explain all the steps and do all that.
Or I can imagine you were doing a lot of like post-processing on vision data, or like, this is wrong, presumably now you don't need to
tremendous
now I think the
advancement.
latest models have their own chain of thought embedded. Like basically, I think 4.0 has chain of thought embedded in it. So
That's
it's
the providing that translation.
Is it 4.0 or it's the new like strong? I don't know. I think at least after what I recall,
Real
experiments,
right?
Yeah. I mean, but the thing is, none of these models are that
To work in healthcare.
But again, our research team is doing it. Yeah, they did say that
that one is way more like there's a lot of API things that aren't It's like always having.
Are you using no, not like we try to steer clear of AI because again we don't know any time like they might say it's GPT-4, but you don't know fundamentally.
Even in healthcare, you're like, I would like more predictability.
Exactly. So we try to rely on open source code.
But I imagine
If 4.0 was like 10 times better. But again, we try to be cautious with using specifically OpenAI because it's like we found the variability to be a lot, right? Especially in terms of predictability of output compared to say obviously you have your own models.
Yeah, that's fair. I read into some of that where it's like, man, I could have sworn this was
this worked yesterday. Exactly.
I always run into the whole like these cases of testing, and it was consistently better than other models. And so it's kind of like, I'll take it 10% better, even if there's like error bars to What's top of mind for you right now?
So right now we're building our platform. So what we are planning to do, we are the orchestration layer. We want to be the orchestration layer. What do we mean by that is, so in healthcare especially, which is more of the, I would say, technology adapting, the inclination to adapt new technology or adopt new technologies compared to say the software side or something that's more on the say Silicon Valley. Healthcare is a bit more slower. So
it is slower, and it's even slower when you're talking about like
exactly. It is fundamentally very slow. So what we want to do is, and the teams also are not, I would say, like the software team, like teams are very so like say if they want to do like a simple summarization use case, they can't do it on their own. So what we want to do is have a platform and provide these agents which are essentially in a sense APIs that they can readily integrate with business. So they have their entire workflow running. They just need to replace this one last step which is just manually entering.
You're loading very quickly. We'll just enter the right API calls from your EMR. We'll go do this work, we'll inject it back into your EMR.
We just save a lot of time. So the thing is, you don't need to replace, like when people say, whether AI is actually like double or whatnot, value that you get from these summarization use cases, because when I do my personal work, as a product manager, 70% of my work is taken care of through AI. When it comes to generating the draft and all that stuff, like say for Jira tickets and stuff. So there's a lot of work that's it's a time saver, but it doesn't replace the work that we need to do. So those are the aspects when it comes to all these businesses also that we do.
I mean, that's my take as well for a lot of this.
Exactly. That's not happening.
It seems unlikely.
And like the whole problem around reliability, consistency is something. How do you bring into production grade is where we are looking at. And I think we'll probably get there where the threshold of around 85% consistency is like amazing. I don't think we're there yet. So that's where we're trying to make sure we're putting as many constraints as possible. We work with a lot of third-party stuff, startups as well, to ensure that we try to make it as specific as possible, constraints as possible. Yeah, it's a lot of fun. But yeah, it's a lot of work as well. And then my work is like this is like the biggest part of my work you're talking about. And most of the work is just making sure that we have these products running.
Well, at this point, like a lot of it is client service.
10 years, and that was
it?
A good portion of it, but not entirely, because we do have our own, the platform that we have is more of a SaaS based services.
Like I wanted to do something.
Sure. Yeah, I was just imagining
What are
like.
we doing next?
Well, actually,
Are we doing
a
it?
question, but like, yeah, what's the breakdown between like we're working on the platform versus like corporate?
I mean, what do you think of
like,
this? My first time being here. My first time
Is it like
being
50
here.
or is it like?
Yeah, I would say
And they want to like control the.
yeah, and Dai Honey both, so it's like, you know,
And they want to like look at the second accounts.
because
So, I wanted to like go to Jetson.
because this one makes money, the client stuff.
Right.
This one is more, you know, yes it does, but then you need to have like, you know, we're still building out something.
But I'm just counting on this as a passive.
Yeah, but those are like.
Yeah, it's nice talking to you.
Trace,
Yeah, so you're looking at a grid system.
A grid system and it moves really fast. Yeah, so I was thinking, so have you heard of this?
Yeah, do you come here often?
Company
This is the first time I've been.
that
Oh, yeah,
just
me too.
manufactures
Fun.
cameras
Yeah,
and
again.
lenses called
But yeah, if you figure out what the eval framework is.
No.
Oh yeah, yeah, we can connect on LinkedIn, you can just send me a message.
I
feel like it is
like
one of
their
those
product.
problems that
Yeah, I'm sure they do. I mean, I wasn't explaining it the way I.
No. Well, I think it. Yeah.
Oh yeah, okay, yeah,
It's
see.
like 800 hertz.
I think it is a thing that everyone's going to have to start integrating into like
All of that will be.
at least their product process, if not their product. Where it's like you want more people to trust it, they're going to use ways to like tell it in a systematic way. Here's what's going on. And make changes and be like, yeah, I mean, this is better than this. Yeah, otherwise like we sell this to. So really imagine, oh, we put in some of these things and then they came up with scale. What do we do? Paralysis of like, I don't make it worse.
No, I think there's a way. I just don't know what the team is doing. I've not been able to privy, or at least I've not confronted enough, because that was more on the data science team that was doing it. But there is, I think they're doing something about it. So
Yeah, which I think is where it starts. It's like it's a data science problem. My hypothesis is that it becomes more of a product problem.
yeah, it has to. Yeah.
Like a product organization problem, and then actually a product problem. That could be wrong. I don't know.
No. I think.
Alright. It was great to meet you.
Yeah, it's nice to meet you.
We'll see you around.
Oh yeah, sure. I don't know like when the next one is. But yeah,
Sounds good.
On device processing, I think if it's fast, you're gonna want something like that. But now, if you start going into the sub-millisecond processing rate, then at that point, just think the dedicated machine learning cameras are so fast. I can process probably a frame with like an on-run controller, on-run controller, and every frame and like 100 measurements in like less than 5 milliseconds.
I assume they have their like on the
Those are like, once you start getting into really high speed stuff, there's really big players in there that kind of dominate that space.
And they don't want to like let open source.
They don't, and they're really good at, there's no reason to do that because they're designed for machines that are producing them.
Yep, absolutely. Big factories.
Right, they're factory driven stuff, whereas AI is really play a role.
Thank
almost
you.
on the angle
Yeah,
of
thank you very much.
where you're dealing with very unstructured manufacturing, right? Where things are just moving and not very structured in a way. Because the problem with like traditional machine vision is extremely powerful and fast, but everything has to be very controlled. You can't have stuff moving around too much and everything has to be the same. But yeah, I see AI really capturing like when you have factories where people are moving stuff and turning
On conveyor belts.
yeah, a lot slower stuff, but a lot more dynamic. Lighting changes all the time, right? So machine vision, like you kind of get that trade-off with machine vision is really, really fast, but everything has to be environment has to be very, very controlled. Where AI is uncontrolled. But yeah,
people definitely train for the second scenario, right? Like how will you train for such a scenario?
for high-speed stuff,
No, for high speed it's a bit easier because it's a repetitive process. You can collect a lot of data just by recording it for a while, then just training something by making someone sit and annotate it. But the other unstructured, uncontrolled environment that you can't train much on.
that's harder to do. You can, but it just takes a lot more effort. It's all about building good data sets. What would be an example?
Yeah, you can
of,
add
such
me
a
on
scenario?
LinkedIn.
Yeah,
Yeah,
like, let's say a car
Yeah,
mechanic, right?
yeah.
I'm under the hood
That's
of a
more
car,
like they talk
and
about
today I got a Toyota Corolla, and I'm taking the
Yeah.
alternator
Yeah.
out, and I'm taking out this and taking out
But
that,
they
and
don't
then
like
next day it's
organize
100%,
it.
it's a different thing,
Depends on
and the next guy does it, he takes the part out, and he flips it, it looks a little bit different, so those are unstructured areas, where in a factory, you're running model, Honda, alternator, everything,
shiny,
everything's exactly the same, and it's very, very quick, so
Yeah.
the unstructured one, the way you would train it, is you
Yeah.
have to,
I
it's a
agree.
lot of mechanical things. And build a big data set. But once you have a good data set, it works very well.
And you can have surprisingly small data which can like influence these good visual language models, right? Like
Well,
tune them.
everything has to be
Yeah,
data
I mean, I think I get
So like, to me, like, what I've learned
So we
about
have
training
global
models
models.
is
Yeah.
don't pay attention to the model. It's all about the data. If you have good data, any model will pretty much get you to the end.
That's what happened to traditional
Yeah, I have a lot of questions.
Yeah.
So like I work in a
Yeah, sure.
and our use case is like very sort of different than certain. There's no time constraint, there's no resource constraint. You could put how well can you identify.
Thanks for coming.
Yes, same here. I think yes.
Alright, yeah, you too, man. Good luck.
Yeah, see you.
Absolutely.
Yeah,
Good
so,
luck.
how will
you identify whether a person is we just need to be accurate. If you're saying this person is living for 20 months, you
better be right.
right? So, and it's like a very open
Yeah, so you go to our website,
open
there is,
ended
you can like register
and there's no
or
data.
subscribe to our mailing list,
CT
you
scans
get
are
notifications.
expensive.
For every event.
You need 10 CT scans or 5 CT scans per person to even be able to make something.
Oh yeah, sure.
And to get someone to annotate a CT scan, you need a radiologist, which will charge
you need
$5 per
others.
CT scan.
Yeah.
So it's like $1 million data set, hundreds of millions of dollars of data set, which my company actually has.
Yeah.
We're trying to like solve these things. So I also run the open
AI transformation for
There's a lot of, but the domain is
healthcare industry.
We are mostly 3D
To extend in other industries.
Yeah, you're dealing with a different type of
Yeah, thank you for coming.
But that's where it's at. It's all about
Or
like,
just some information
at least with
somewhere
current
somewhere
models.
else,
You know,
or-
unless until somebody.
Yeah, this is all live stream. So if you want to like, if you
Currently,
want
everything I've ever seen
see
is
the
still
live
limited by
Gotcha.
data,
Yeah,
right? Like
data
data
share
is the
table
key
analysis.
for customized
Yeah.
applications.
Yeah.
Now, if you're
We
using
were actually
applications that are trained on like very openly available data
Yeah,
sets,
I came here late
pull
as
it all
well.
down, train it on.
Well,
I just want to do red cards and it'll be able to do it, but if it's doing something very
So when you talk to let's say like client, what are the questions?
Yeah. So we had a hackathon for last August. We're planning to do
No,
one
who will
more
annotate
in,
that data?
spring.
I just, the number one thing I
So we
look
have,
for
we plan to
is
have two
just
hackathons
understanding
per
what
year.
they're
So
trying
one
to
in
do.
the
What are you
summer or
looking
one
for?
in
What are you
spring.
trying to do, right?
There's also, it doesn't make sense to have a solution which might work with it.
They usually come to me like, I'm doing this and I think computer vision will help. So at that point, really, I mean, it's focusing on what exactly they're trying to execute, because sometimes AI.
But yeah, nice presentation, nice.
And if they do not use AI, I do see that. Pretty much, I need to capture all the variables, so I look for the cost of acquiring that variance, and that's what I'll be charging.
Oh, okay.
How much money you have to spend to get all the data.
Yeah, so we have self-driving trucks.
And usually it's expensive.
And
but
we are owned by.
you know, so most of the customers I run into, they're not shy to drop good money to make that happen. But yeah, it's
core,
really very
machine learning
customized, and I have to sit down
so we
and understand
designed
what they're trying to do.
And then do they
Training
deploy that model
orchestration.
on their own machines? Like, do you, I
Or
heard you talking
yeah,
about like
we have the
cameras which
framework
have their
team, so we write a
processors
wrapper
on it.
around PyTorch.
I'm guessing that the
Which
factories and the
does
manufacturing units are
training,
working, have their own machinery or have their own hardware.
clusters,
Or
yeah,
then
that's
you
the
like
one.
introduce new
Scaling
hardware.
of it.
Yeah, you can, because everything runs on a central PC called PLC, right? So the PLCs are just PCs, and what you would do is, if I have a new tool that I'm giving you, and you want it to do this specific task, and you just want me to send the data to the PLC, it's just a common bus, right? Modbus, OPC,
So
whatever.
all the inputs from the whole unit are basically processed to central.
Well, they're just sent to it, so I'll process and then send over pass-fail data or measurement data.
This is like the controller.
Yeah. The PLC is like the master machine. So, hey, I got a machine running and it's already got a PLC on it. I wanna put a computer vision system. So the way it would work is I would deploy a computer vision system with its own processor that would talk to the PLC and send it the summary of the data, right? I did a measurement, I concluded this part's good, and then here's all the log of everything that's finished, so you can take that part and reject it at the end, or pack it, or
So
do
action
whatever.
is done by PLC.
Right.
You just give it another input essentially. to
Right,
program.
I'm just another sensor that's talking to it, but it's a sensor with more intelligence, right? So it's just a single node that is giving it one more level of vision, essentially, right? The PLC is the brain, the AI is essentially just a set of eyes, right? And it's like telling you, hey, this is what's going on, and you can make the decision on what you want to do with it later, right? But it's a big field, man. It's a really big field. I really believe that this is just in 10 years. We'll
And
be
then the
looking
real world
back,
testing, of course, needs
back at this in amazement, like just how much it's
Things are
evolved.
moving very quickly.
It's
simply
too
remove the
fast.
driver.
But I'm gonna get out of here, man. It's good meeting you. What's your name?
But we are running for
Shit,
the
there? Yeah, here, connect me here.
Yeah, I think the revolution will happen fast
You
enough.
can scan my code.
Yeah, it's right there. Like we are all chasing the long tail.
Sure, it's Justin Clay.
The edge cases. And so we are building
Yeah.
this.
No, there it is.
All
right
these
there.
people in
Justin C.
we have a safety
Awesome.
department
Yeah.
that is building.
All right, man.
these
Hey, good meeting you. Drive safe.
and
I'll see you
safety
later.
case is like a bunch of.
This is GTFO.
It's like a framework to build all this data
Good night.
in like a structured format.
Yeah.
Yeah, so that they can show that to the regulatory body to give us permission to slowly the drivers. Yeah, it's like this many miles driven, this many disengagements, and why these disengagements happen, what are the reasons.
Politics
I am not, but I'm here.
Yeah, moving through it.
So it's quite possible that the next
Yeah.
popping out of nowhere.
Yeah. So,
I guess, yeah.
So you're primarily, so your expertise is primarily hardware.
Yes,
This is gonna be like
so
the
that's pretty much
most
what we do,
like uncertain election, I guess, since I was born. Like,
So we do like
it was like
Raspberry Pi.
hints or whatever, I guess.
Now we're doing like NVIDIA,
Yeah.
these are all like hardware pieces we do.
And like with the
And we
hurricane now, you have,
mostly do right now, like we build these
enough
devices, like our own
people
devices,
talking about
we
weird
like
things
this
going on
more to
with
commercial level,
yeah.
and then we have like
Generating hurricane and stuff.
industrial
And
level.
so,
yeah,
And then
it's,
another part of our
I
business
mean,
is to help
yeah, I've read books.
once-
developers, like
about-
individual developers,
Well,
to
once-
come
fiction
in
books.
with their
well, the
pieces.
thing is,
So
you can't know
helping
the
them,
truth
like,
from what's not true because everything's
manufacture,
classified.
provide
Yeah.
But,
PCB
progressively
boards,
things are being
like,
declassified,
you
but
know,
once the whole
if
shit
it's
is up,
PLC, we help them go to productions, we do like
create a very
small
different
pieces to
perception
start
of
with,
what
like
is
a
possible.
vendor,
Yeah, absolutely.
I guess regulations and
that's another part of our
I mean, honestly, I don't think we care about the election government. I think they are all
obvious.
Right.
The real
They
government
have a purchase
is the one who actually like
all of their
disrupts
lives, smart lights with it,
and no one
they try to
interact.
Well, that's-
not
that's
Democrats,
what-
not.
But if you just
They're all
just
afraid to
smarter,
like
they
change.
all go.
The thing is, if you have two
It might take
parties
a
in the
different form,
government,
but the core might be
Yeah.
then you
like
break
something like this, where you have an agent and then there's a physical embodiment of that agent.
But that's
Yeah,
already like hating
that's the
each
thing,
other.
like, we-
Yeah,
So
but
there's
the-
nothing breaking.
but
Like,
of course,
yeah.
the hate is
Yeah.
building up.
Yeah, yeah.
And I guess at this point, you're kind of getting to one of the highest
And it's
levels.
offline, like,
Yeah.
this is
It's
not-
like the threshold. I guess like it's probably the first time that you have two assassination attempts on one of the candidates.
Yeah.
The first time that you have
like, I don't even have my cameras in my home right now, because I know
yes
no matter how
the level
secure it
of
is, people are gonna use
fear
it.
on each
Yeah,
side.
yeah, fear is
No,
crazy.
that's-
Yeah, the
no,
hatred
that-
is crazy.
you don't even
Yeah,
have to
there's
have
like
it
polarization
like,
happening.
if you have a camera.
So what I
you
mean by
have
like
it.
I don't really care about the government is
So these things
doesn't affect
you
me.
can connect with anything.
because at the end of the day,
Only talking to your own
I am
devices
really
and your
like
own network, that's
caring about
perfect.
regulation that's really like
Yeah, I'll definitely look into it.
all these
Sure.
all the policy
Yeah.
changes that each of the government or
Alright.
candidate talks about are like
Yeah,
shallow.
what they're talking about is shallow, but I guess with most of the regulation you have for like the bigger industry are like deals that they have with like GM or other big companies.
Yeah, these
And
lobby
the
powers
thing
are-
is once you get enough mess to get the corruption like to be public, then the corruption falls, and once the corruption falls, then the regulations fall, and that's where you have the real change.
Yeah, but that's not gonna happen anytime
Well,
that I can think of.
I think we're closer to the threshold now than we've ever been.
And if it's not, like this election will be on next way, so
We'll see.
within the next 5 years,
Yeah,
things will change.
I hope so. But yeah, nice. Thanks.
Thank you guys so much.
Well,
yeah, very nice.
nice
to
meeting
see
you.
Yeah. Okay. Yeah. Take care. Bye bye.
Yes, I'm leaving soon. I'll turn
Close
off
the door.
the-
Yeah.
Ends up in